In the final months of World War II, deep within occupied Japan, a small group of Imperial Navy pilots and engineers made a discovery that would challenge everything they believed about their own fighter supremacy. When American F-4U Corsairs force-landed near Japanese territory in early 1945, these men were given an unprecedented opportunity to fly the enemy's most feared weapon. What they learned in those secret test flights near the Kasumigara Naval Air Station would force them to confront an uncomfortable truth about the aircraft they had trusted with their lives for years. This is the untold story of the men who flew both sides of the Pacific War, and the 417 miles per hour that changed everything they thought they knew about air combat. If you're fascinated by untold stories from World War II aviation history, hit that subscribe button now. What you're about to hear is based on verified historical records, declassified intelligence reports, and first-hand accounts from the men who were there. The morning of February 25, 1945 dawned cold and gray over central Japan. Lieutenant Commander Minoru Genda stood at the edge of Kasumigara Naval Air Station, watching as ground crews worked frantically on an aircraft that should not have been there. The sleek, bent-wing silhouette of an American F-4U Corsair sat incongruously among the rows of Mitsubishi Zeros, its dark blue paint bearing the scars of forced landing just hours earlier. The pilot, whose fate Genda did not want to contemplate, had put the fighter down in a field near Tsukura City in Ibaraki Prefecture when his engine began failing during a strike mission against the Japanese mainland. Now, as February wind cut across the tarmac, Genda found himself facing a machine that had become the nightmare of every Zero pilot still flying. The Corsair had arrived in the Pacific Theater in early 1943, and its impact had been immediate and devastating. American Marine pilots called it various names, some affectionate, some fearful. The Japanese had their own name for it, the Whistling Death, for the distinctive sound its air intakes made during high-speed dives. By 1945, the kill ratio spoke for itself. 11 Japanese aircraft destroyed for every Corsair lost. 11 to 1. These were not the numbers of an evenly matched contest. They were the mathematics of technological superiority translating directly into dead pilots and burning aircraft spiraling into the Pacific. Genda was not a young pilot anymore. At 36, he had survived longer than most, flying since before the war when the Zero had been new and seemingly invincible. He remembered the early days vividly, the intoxicating period when Japanese naval aviation dominated every engagement, when the sight of the Hinamaru red circle on their wings sent Allied pilots fleeing for cloud cover. That era felt like ancient history now, belonging to a different war fought by different men with different aircraft. The Zero that had ruled the Pacific skies in 1942 was still essentially the same aircraft in 1945, while the Americans had moved forward with frightening speed, producing fighters that outclassed the aging Japanese designs in nearly every measurable category. The captured Corsair represented more than just an intelligence opportunity. It represented the technological chasm that had opened between Japan and the United States, a gap that widened with every passing month as American industry churned out new fighters while Japanese production struggled under bombing, raids, and resource shortages. The technicians at Kasumigara had already begun their examination, measuring, photographing, documenting every aspect of the foreign fighter. But measurements and photographs could only reveal so much. The real test, the one that mattered to pilots like Genda, would come when someone strapped into the cockpit and pushed the throttle forward. The Yokosuka Naval Technical Arsenal, located about 50 kilometers south of Kasumigara, had sent their specialists north when word reached them about the captured American fighter. These men were not pilots but engineers, trained in aerodynamics and structural analysis, tasked with understanding how Allied aircraft achieved their performance characteristics. Chief among them was Technical Commander Takeshi Nato, a graduate of Tokyo Imperial University who had spent the war years evaluating captured Allied equipment. Naito had examined crashed Wildcats and Hellcats, studying their construction methods and material choices, always searching for insights that might help Japanese designers narrow the performance gap. But the Corsair was different. Even sitting motionless on the tarmac, its inverted gull wings and massive radial engine projected a sense of purposeful aggression that the other American fighters lacked. NATO's first observation, recorded in his official report dated February 26, 1945, noted the Corsair's surprisingly heavy construction. Japanese fighters, particularly the Zero, had achieved their legendary maneuverability through ruthless weight reduction, sacrificing armor protection and fuel tank sealing to keep the aircraft as light as possible. The philosophy made sense in the early war years when Japanese pilots were highly trained veterans who could exploit every advantage of superior maneuverability. But as those veteran pilots died and were replaced with younger men who had far less training, the lightweight construction became a liability. A single burst from American .50 caliber, Machine guns could shred a Zero's unarmored fuel tanks and set the entire aircraft ablaze. Naito had seen the aftermath too many times, burned aircraft and burned pilots, the price of a design philosophy that no longer matched the realities of 1945. The Corsair took a different approach entirely. Naito found heavy armor plate protecting the pilot's seat and back, thick enough to stop rifle-caliber bullets and even some cannon shells. The fuel tanks incorporated self-sealing technology, rubber layers that swelled when punctured to block fuel leaks. The wings, when NATO's team removed inspection panels to examine their internal structure, revealed construction that seemed almost crude compared to Japanese practice. With heavy ribs and thick skin that added weight but provided tremendous strength. One section of the captured Corsair's wing had been damaged during the forced landing, and the Japanese ground crew had been surprised to discover that some areas were covered with fabric rather than metal. This seemed primitive at first, a throwback to earlier aircraft construction methods, until NATO realized it represented yet another American approach to the weight versus strength equation. The Corsair's designers had used metal where strength was critical and fabric where it was not, achieving a balance that Japanese engineers, always chasing minimum weight, had not considered. But the real revelation came when NATO examined the engine. Phantom Whitney R2800 Double Wasp was a monster, an 18-cylinder radial putting out over 2,000 horsepower. For comparison, the Nakajima engine that powered the Zero produced 950 horsepower at best. The Americans had more than twice the power to work with, and they had used it lavishly. The Corsair did not need to be lightweight and delicate like the Zero because it simply overpowered the laws of physics that constrained other designs. It could carry heavy armor, self-sealing fuel tanks, 6 50-caliber machine guns with ample ammunition, external bomb racks, and still outperform Japanese fighters that weighed half as much. The captured Corsair bore the bureau number 57,251 and had been assigned to Fighting Squadron VBF-85 aboard the USS Essex. The aircraft had launched that morning as part of a strike package targeting Japanese positions around Tokyo Bay, part of the massive carrier raids that had become routine as American naval power closed inexorably on the home islands. Something had gone wrong with the engine during the mission, exactly what would remain unknown, and the pilot had been forced to break formation and attempt an emergency landing. He had put the fighter down wheels up in a winter rice field, and local Japanese troops had reached the aircraft before the pilot could destroy it. The Corsair had sustained damage to its left wing and propeller, but the airframe remained largely intact. Within hours, Army troops had dragged it from the field and transported it to Kasamigara, where Navy personnel could examine it properly. The pilot's fate did not appear in Japanese records, and Genda did not inquire too closely. By February 1945, the treatment of captured Allied airmen had become a dark subject that most Japanese officers preferred not to discuss. The official policy called for captured flyers to be turned over to military police for interrogation and then processed as prisoners of war. The reality often differed considerably from policy, particularly when pilots were captured by Army units far from central authority. Genda had heard stories, whispers really, of captured American airmen who never made it to prison camps, who disappeared into the chaos of a collapsing military system. He did not know if these stories were true, and he told himself he did not want to know. The war had coarsened everyone, stripping away the veneer of civilization that peacetime took for granted. The ground crews at Kasamigara worked through the night of February 25th, repairing the Corsair's damaged wing using fabric patches and salvaged components from other crashed American fighters that had been recovered in previous months. By dawn on the 26th, they had the fighter in what they considered flyable condition, though flyable by Japanese standards in early 1945. Meant something very different than it would have meant earlier in the war. Spare parts were perpetually short. Quality control had suffered as experienced workers were conscripted and replaced with less skilled labor, and the constant American bombing had disrupted supply chains throughout the home islands. The patched Corsair would never have been cleared for flight by American standards, but American standards were a luxury Japan could no longer afford. The question of who would test fly the captured fighter generated considerable discussion among the officers at Kasamigara. The Corsair was known to be a difficult aircraft to handle, particularly during takeoff and landing. American pilots called it the Ensign Eliminator because it had killed so many inexperienced Navy pilots during carrier qualification training. The fighter's long nose obstructed forward visibility on the ground. Its powerful engine produced tremendous torque that could flip an unwary pilot if not properly managed, and its landing characteristics were notoriously unforgiving. Several Japanese pilots had experience flying captured American aircraft, but the Corsair represented a significant step up in both performance and difficulty. From the Wildcats and even Hellcats they had previously evaluated, Genda volunteered. He was senior enough that he could have delegated the dangerous first flight to a junior pilot, but something in his character would not permit it. He had been flying since 1931, had accumulated thousands of hours in everything from trainers to the latest Japanese fighters, and had survived this long precisely because he understood his aircraft and his own limitations. The young pilot still arriving at Kasumigara had perhaps 50 hours of flight time, barely enough to solo, much less handle a high-performance fighter in challenging conditions. If the Corsair was going to be flown, it should be flown by someone who had the experience to learn from it rather than simply die in it. The morning of February 27, 1945 broke clear and cold. With visibility unlimited, the kind of weather that occurs only rarely in the Japanese winter, Genda arrived at the flight line before dawn, wanting time to familiarize himself with the Corsair's cockpit before attempting flight. The American fighter's instruments were labeled in English, which Genda could read adequately, though not fluently. He had studied English at the Naval Academy, as had most Japanese naval officers of his generation, though his fluency had declined during the war years when speaking English became socially unacceptable. Now sitting in the Corsair's cockpit running through the pre-flight checklist that NATO's engineers had translated and typed out in Japanese, he found himself grateful for those long-ago English classes. The cockpit layout differed significantly from Japanese practice. The Americans favored large, robust instruments clustered directly in front of the pilot, while Japanese designers tended toward smaller gauges arranged in patterns that saved weight but required more interpretation. The Corsair's throttle quadrant was on the left side of the cockpit, massive and solid feeling compared to the Zero's delicate controls. The rudder pedals sat far forward, positioned for the longer legs of American pilots who tended to be taller than their Japanese counterparts. Genda, who stood 5 feet 6 inches, found the Corsair cockpit almost comically oversized, as though it had been built for men from a different species. The engine start sequence proved straightforward, almost crude in its simplicity. Prime the engine, engage the starter, monitor oil pressure and temperature as the big radial coughed to life. The R-2800 did not purr like a Japanese engine. It bellowed, a deep rumbling thunder that Genda felt through the airframe and in his chest. 18 cylinders displacing 2,800 cubic inches produced a sound that was more felt than heard. A physical presence that announced American industrial might in the most visceral way possible. Genda let the engine warm up slowly, watching the gauges creep toward normal operating ranges. His hands light on the controls, feeling the power barely contained by throttle and brake. Taxiing the Corsair required constant attention and a delicate touch on the brakes. The long nose completely blocked forward view when the tail wheel was on the ground, forcing Genda to stern the fighter as he rolled toward the runway, swinging the nose left and right to see ahead. This visibility problem had bedeviled American carrier pilots and was one reason the Navy had initially relegated the Corsair to land-based Marine squadrons. Genda understood immediately why carrier landings would be nightmarish in this aircraft. Landing on a carrier deck required precise control at slow speed with the tail high to see the landing signals officer, exactly the flight regime where the Corsair was most dangerous. The takeoff run began smoothly enough. Genda advanced the throttle gradually, feeling the Corsair accelerate with startling rapidity as the big engine developed full power. At 40 knots, he brought the tail up, and suddenly he could see ahead, the runway stretching before him, clear air beyond. The acceleration continued building faster than any Japanese fighter could manage, pressing him back into the seat as the airspeed indicator wound rapidly through 60, 70, 80 knots. At 90 knots, he eased back on the stick, and the Corsair broke ground cleanly, climbing with an authority that took his breath away. This was what power felt like. Not the marginal surplus of the Zero, always on the edge of its performance envelope, but massive, overwhelming power that made altitude come easily. Genda climbed to 10,000 feet and leveled off, running through basic handling tests. The Corsair felt heavy compared to the Zero, less responsive to small control inputs. But the controls were perfectly harmonized and predictable. Roll rate was excellent, better than he expected given the fighter's size and weight. Rudder effectiveness was good throughout the speed range. The Americans had clearly spent considerable effort on the Corsair's flying qualities, creating an aircraft that was stable and predictable even when pushed hard. This was engineering conservatism, building in margins that allowed even moderately skilled pilots to survive. Exactly the opposite of Japanese practice, which demanded expert pilots to extract maximum performance from lightweight marginal designs. The speed tests came next. Genda accelerated in level flight at 10,000 feet, pushing the throttle to its forward stop and waiting for the airspeed to stabilize. The needle climbed past 200 knots, past 220, settling at 230 knots indicated. He did some quick mental math, converting to miles per hour, accounting for instrument error and compressibility effects. The Corsair was making about 360 miles per hour at 10,000 feet, considerably faster than even the best Zero models could manage at that altitude. But the Corsair's critical altitude, the height at which the supercharger allowed the engine to develop maximum power, was much higher. Genda climbed to 20,000 feet. the big R2800 pulling strongly through altitudes where a Zero's Sakaya engine would be gasping for air. At 20,000 feet, he repeated the speed test, and this time the results were even more impressive. The airspeed needle stabilized at 240 knots, indicated about 380 miles per hour true airspeed after corrections. This matched almost exactly the performance data in the captured flight manual that NATO's team had translated. The F4U-1 had a maximum speed of 417 miles per hour at 19,900 feet. Jenda was slightly above that altitude, and his indicated speed was close enough to confirm the published figures. 417 miles per hour. Jenda let that number sink in as he orbited over Kasumigara. The captured American fighter responding smoothly to his inputs, docile and predictable in a way that belied its fearsome combat reputation. 417 miles per hour in level flight. The best Zero models, the late A6M5 versions with the improved Sake engine, could manage perhaps 351 miles per hour at their critical altitude. The gap was not close. It was not even competitive. The Corsair was simply faster, by margins that made tactical mockery of Japanese fighter tactics. The implications crystallized in Jenda's mind as he flew north toward Mount Tsukuba, its snow-covered peak visible 50 kilometers distant. Everything Japanese pilots had been taught about fighter combat assumed roughly equivalent performance between opponents. If you could not outrun an enemy, you could outearn him. If he could dive away, you could follow and regain position. The Zero's legendary maneuverability had been Japan's equalizer, the factor that allowed skilled pilots to overcome small performance disadvantages. But the Corsair eliminated that equalizer. An American pilot in a Corsair could simply refuse to fight on Japanese terms. If a Zero got on his tail, he advanced the throttle and pulled away, gaining separation until he could reverse and attack from a position of advantage. The Zero pilot could do nothing about it. He could not catch the Corsair in level flight. He could not follow it in a climb. He could not stay with it in a dive. This was not a small problem with a clever tactical solution. This was a fundamental mismatch that no amount of pilot skill could overcome. Japanese fighter tactics had evolved in an era when performance parity existed or when Japanese fighters held the advantage. Those tactics assumed the enemy would fight, would commit to turning combat where the Zero's superiority could be decisive. But American pilots and Corsairs did not have to fight on those terms. They could engage when advantageous and disengage at will, using superior speed and climb rate to dictate every engagement. The Japanese called this hit-and-run tactics as though it were somehow unsporting. But it was simply intelligent use of superior technology. Jenda brought the Corsair back to Kasumigara after an hour in the air, his mind full of uncomfortable conclusions. The landing proved as challenging as takeoff, requiring precise speed control and constant vigilance. The Corsair wanted to float during the flare, its large wings generating lift efficiently even at slow speed, and Jenda had to force it onto the runway with deliberate forward stick pressure. The fighter bounced once, typical of the type according to American reports, then settled onto its main wheels. He let the tail wheel come down and immediately sterned again, unable to see straight ahead, trusting the ground crew's signals to guide him to the parking area. After shutdown, Jenda sat in the cockpit for several minutes, collecting his thoughts before facing the questions he knew would come. NATO and several other technical officers stood near the wing waiting for his assessment. What could he tell them? That the Corsair was an excellent fighter, beautifully harmonized and possessing performance that made the Zero obsolete? That the 417 miles per hour maximum speed was not an estimate or propaganda, but a cold fact that he had just verified personally? That the technological gap between Japanese and American aviation had grown so wide that no tactical innovation could bridge it? He climbed down from the cockpit and walked to where the engineers waited. The morning had turned colder, wind from the north bringing the smell of snow. NATO had his notebook ready, prepared to record every detail. The other officers watched Jenda's face, searching for reactions, hoping perhaps that the Corsair had some fatal flaw they could exploit, some weakness that would restore balance to the equation. Jenda chose his words carefully, speaking to the assembled group. The Corsair was fast, he said, using understated language that Japanese military culture valued. It was significantly faster than any Japanese fighter in level flight, particularly at medium and high altitudes. The published performance data appeared accurate. The fighter's construction was extremely robust, heavier than Japanese practice, but providing margins of safety that protected the pilot. The engine was powerful and reliable, at least during his brief flight. The cockpit layout was logical and the instruments were easy to read. Visibility in flight was good, though ground visibility presented challenges. Handling was predictable throughout the speed range. There were no unpleasant surprises, no vicious characteristics that would trap an unwary pilot. And then he said the thing they needed to hear but dreaded hearing. No Zero variant could match the Corsair in level flight. Not close. Not with any realistic margin. The speed difference was simply too great. An American pilot who maintained discipline and used his aircraft's advantages properly could not be caught by a Zero. The best Japanese pilots might score kills through surprise or numerical superiority or American mistakes. But in a 1-versus-1 engagement between competent pilots, the Corsair held overwhelming advantages that negated Zero maneuverability. The silence that followed his assessment stretched uncomfortably. Naito wrote steadily in his notebook, recording Genda's words verbatim. The other officers stared at the captured Corsair as though seeing it clearly for the first time, understanding what it represented. This was not just an enemy fighter. It was physical evidence of American industrial and technological superiority. A superiority so pronounced that it had rendered Japan's most famous fighter effectively obsolete. Someone asked whether modifications to the Zero could narrow the performance gap. New engines perhaps, or streamlining to reduce drag, anything that might restore competitive parity. Genda shook his head slowly. The gap was too large. It was not a matter of tuning or incremental improvement. It was fundamental difference in approach. American willingness to build heavy fighters with massive engines versus Japanese focus on lightweight agility. The latter had worked brilliantly in 1942 when American fighters were slower. It no longer worked in 1945 when American fighters were faster and also stronger and better armed and built in numbers that Japanese industry could never match. The captured Corsair remained at Kasumigara for several more days while NATO's team completed their technical evaluation. Other pilots flew it, confirming Genda's observations, adding their own notes about handling characteristics and performance. The consensus was unanimous. The Corsair represented a level of engineering sophistication and manufacturing quality that Japan could not match given its current industrial capacity. Even if Japanese designers created a paper design that matched Corsair performance, and even if factories could be found to build it, and even if materials could be sourced despite bombing and blockade, the time required would extend beyond any reasonable estimate of how long the war might continue. This last point, unspoken but understood by everyone involved, hung over the entire evaluation. By late February 1945, informed Japanese officers knew the war was lost. The question was not whether Japan would be defeated, but when and under what terms. The massive American carrier raids, the relentless strategic bombing, the tightening blockade that strangulated imports of raw materials, all pointed toward inevitable conclusion. The captured Corsair was interesting from a technical standpoint, useful for understanding American design philosophy and manufacturing methods, but it could not change the trajectory of the war. The information gained from testing it might inform future Japanese aircraft development, but future in this context meant post-war years, an era when military aviation would be shaped by very different requirements. The Emperor's decision to surrender would not come for another 5 months. 5 months of increasingly desperate fighting as American forces advanced through Okinawa, and strategic bombing reduced Japanese cities to ruins. During those final months, the captured Corsair at Kasumigara became something of a curiosity, occasionally flown by visiting pilots but no longer the subject of intensive study. There was no point. The technical lessons were clear, and there was no time to implement them even if resources had been available. The war had moved beyond the point where technical insights about enemy fighters mattered. In early August, as rumors of a powerful new weapon circulated through military channels, someone made the decision to destroy the captured Corsair before American forces arrived to reclaim their territory. The aircraft was pushed into a revetment and burned along with other captured Allied equipment, preventing its return to American hands. When U.S. occupation forces reached Kasumigara in September 1945, they found the burned remains of what had been the Zero's nemesis, reduced to twisted metal and ashes. The technical reports that Naito and his team had compiled disappeared into the chaos of surrender, most likely destroyed as potentially embarrassing documents that revealed the extent of Japanese technological inferiority. But the memory persisted among those who had been there. Genda survived the war, went on to serve in the post-war Japanese Self-Defense Forces, eventually retiring as Chief of Staff of the Air Self-Defense Force in the 1960s. He rarely spoke publicly about the captured Corsair, but in private conversations with trusted colleagues, he would sometimes reference that February morning in 1945 when he had flown the enemy's fighter and understood, with perfect clarity, how outmatched Japanese aviation had become. The number stayed with him. 417 miles per hour. It was more than just a statistic. It was the quantification of defeat, the measurement of an unbridgeable gap between what Japan could produce and what America was producing. Other Japanese pilots who encountered the Corsair in combat developed their own understanding of that gap, though from a less analytical and more visceral perspective. By 1945, the typical Japanese fighter pilot had perhaps 30 hours of flight training, barely enough time to learn basic flying, much less the sophisticated energy management tactics required to survive against superior American fighters. These young men died in horrifying numbers. shot down by American pilots who had hundreds of hours of training in aircraft that gave them every advantage. The Americans called it a turkey shoot, a term that captured the one-sided nature of air combat in the war's final year. The 11-to-1 kill ratio was not the result of Japanese pilots being cowardly or incompetent. It was the inevitable result of sending inadequately trained pilots into combat and obsolete aircraft against veterans flying technically superior fighters like the Corsair. The technology gap extended beyond just top speed, or Corsair's 650 caliber machine guns, synchronized to fire through the propeller arc, delivered firepower that the Zero's 2 cannon and 2 machine guns could not match. American ammunition was more reliable. Their gun sights were more accurate. Their gun sight ranging was more sophisticated. The Corsair could carry bombs or rockets for ground attack missions that the Zero could theoretically perform but for which it was poorly suited. The Corsair had redundant systems and robust construction that allowed it to survive damage that would destroy a Zero. American pilots brought home Corsairs with entire sections of wing missing, with engines shot full of holes, with control cables severed. Japanese pilots died when single bullets punctured their unarmored fuel tanks. This disparity in survivability reflected fundamental differences in design philosophy and industrial capability. American aircraft manufacturers built redundancy and damage tolerance into their designs because they could afford to. They had the materials, the manufacturing capacity, and the engineering expertise to create aircraft that prioritized pilot survival. Japanese designers could not make those same choices. Operating under severe material constraints and limited industrial capacity, they optimized for performance and range at the expense of protection. This made sense given Japan's strategic situation and resource limitations, but it exacted a terrible price in pilot casualties. The human cost of technological inferiority is difficult to quantify precisely. Japanese naval aviation lost approximately 20,000 pilots during the Pacific War, with casualties accelerating dramatically in the final 2 years as American fighter superiority became absolute. Some of these losses came from combat with Corsairs, specifically, though separating Corsair kills from kills by other American fighters like the Hellcat and Thunderbolt is impossible from surviving records. What is clear is that by 1945, Japanese pilots had lost faith in their aircraft and their chances of survival. The combination of inadequate training, obsolete equipment, and overwhelming enemy numbers created a psychological burden that affected combat effectiveness even before pilots engaged the enemy. The captured Corsair represented something more profound than just a faster fighter. It was physical evidence of the industrial war that Japan could never win, the war of production capacity and technological advancement that American industry waged with remorseless efficiency. For every Corsair shot down, American factories built 10 more. For every American pilot killed, training programs graduated 20 more. Japan could not match this output. Japanese aircraft production peaked at about 28,000 aircraft in 1944, a number the Americans exceeded in the first half of that same year. The Americans were not just winning. They were winning with such overwhelming material superiority that Japanese resistance, however determined, could only delay the inevitable. The technical specifications told part of this story. The F4U-1 Corsair weighed 8,982 pounds empty and 12,039 pounds loaded. It could carry 1,000 pounds of bombs or 8 rockets in addition to its 6 machine guns. It had a range of 1,015 miles on internal fuel, extendable with drop tanks. Its service ceiling was 36,900 feet. Rate of climb was 3,250 feet per minute. And that maximum speed, verified personally by Genda and other Japanese test pilots, 417 miles per hour at 19,900 feet. The Mitsubishi A6M50, the best version in production during 1945, weighed 4,136 pounds empty and 6,025 pounds loaded. It carried 2 20mm cannon and 2 7.7mm machine guns. Range was exceptional at 1,194 miles, reflecting the Zero's long-range design priority. Service ceiling was 36,250 feet, roughly equivalent to the Corsair. Rate of climb was 3,100 feet per minute, also comparable. But maximum speed was only 351 miles per hour at 20,000 feet, and that was the newest version. The older A6M2 models that still equipped many units could manage only 331 miles per hour. The speed gap was 66 miles per hour between the late Model Zero and the Corsair, enough that the American fighter could simply fly away from any engagement that turned unfavorable. This speed advantage translated directly into tactical dominance. American doctrine for fighting Zeros emphasized boom and zoom tactics, diving attacks from altitude that used superior speed and power to generate energy for rapid climbs back to safe altitude. A Corsair pilot would patrol at high altitudes, scanning for Japanese fighters below. When he spotted targets, he would dive, building speed to 400 miles per hour or more. fire a burst from his 650s, then zoom climb back to altitude before the Zeros could react. If a Zero somehow got on his tail during the attack, the Corsair pilot would simply push the throttle forward and extend away, using his speed advantage to open the range until he could reverse or climb or simply disengage entirely. The Zero pilot could not follow because his aircraft lacked the speed. He could not climb with the Corsair because of inferior power-to-weight ratio. He could not dive with the Corsair because the Zero's lightweight structure imposed speed limits that made high-speed dives dangerous. Japanese pilots understood these limitations intimately, having learned them through bitter experience. By 1945, standard Japanese defensive tactics against American fighters emphasized tight formation flying and mutual support, trying to create overlapping fields of fire that would deter diving attacks. But this defensive posture surrendered initiative to the Americans, allowing them to attack when and where they chose. It was fighting from weakness, trying to minimize losses rather than achieve victories. And it reflected the reality that Japanese fighters could no longer contest American air superiority on equal terms. The captured Corsair test flights documented this reality with scientific precision. Genda's reports, NATO's technical analyses, and the observations of other test pilots all reached the same conclusions. The Corsair was faster, stronger, better armed, and built in numbers that overwhelmed Japanese production. No amount of pilot skill could overcome these material disadvantages. The 417 miles per hour maximum speed was not just a number. It was the measurement of how completely American industry had surpassed Japanese capabilities. In the decades after the war, historians and aviation enthusiasts would debate why Japan continued production of the Zero when its obsolescence was evident. The answer was simple if unsatisfying: there was no alternative. Replacement fighters like the Mitsubishi J2M, Raiden, and Kawanishi N1KJ Shiden showed promise but suffered from development problems and low production numbers. The Raiden had engine reliability issues. The Shiden was difficult to fly and maintenance intensive. Neither could be produced in quantities sufficient to replace the Zero force. So Zero production continued through 1945 with over 10,000 built by the war's end. Most of them flown by inexperienced pilots who lacked the training to use the Zero's remaining advantages effectively. The post-war period brought reflection on what went wrong with Japanese aviation development. Interviews with surviving engineers and designers revealed a complex picture of bureaucratic infighting, resource limitations, strategic miscalculations, and the simple reality that Japan had started from a position of industrial weakness that proved impossible to overcome once war began. The Zero had been a brilliant design in 1940, achieving remarkable performance with limited resources, but it represented the apex of lightweight fighter design. And when the Americans responded with powerful engines and heavy fighters, Japan lacked the industrial capacity to shift approaches. The Corsair and its contemporaries represented a different design philosophy, one that required material resources and manufacturing capabilities Japan simply did not possess. The story of the captured Corsair is ultimately a story about industrial warfare and technological competition. It is about the limitations of clever design when facing overwhelming material superiority. It is about brave men sent into battle with inadequate equipment, knowing they were overmatched but fighting anyway because that was their duty. It is about a number, 417 miles per hour, that quantified the gap between two nations' industrial capabilities and shaped the outcome of their conflict. For the men like Genda who flew both sides of this technological divide, who piloted Zeros in the early war years when Japanese fighters dominated, and then flew captured Corsairs in the final months when American superiority was absolute, the experience provided perspective that few possessed. They understood viscerally what the numbers meant, how speed and power and construction quality translated into combat effectiveness and ultimately into victory or defeat. They had felt the Zero's delicate responsiveness and understood its limitations. They had felt the Corsair's brutal power and understood its advantages. They knew, in a way that historians and analysts could only approximate, exactly how outmatched Japanese fighters had become by 1945. The technical reports from the Kasamigara tests, assuming any survived the chaos of surrender and occupation, would have documented these conclusions in careful language appropriate for official reports. Maximum speed verified at 417 miles per hour. Climb rate excellent. Handling predictable. Construction robust. Armament effective. Recommendation: no existing Japanese fighter can match F-4U performance. The clinical language would have understated the human meaning behind the numbers. The implication that Japanese pilots were being sent to die in aircraft that could not compete. The young pilots arriving at training bases in early 1945 did not know these details, but they understood the general situation. Veterans warned them that American fighters were fast, that diving away from a Corsair or Hellcat was futile, that survival required discipline and teamwork and luck, mostly luck. These warnings came too late and with too little training time to make much difference. The typical Japanese pilot in the war's final months had flown perhaps 50 hours. Barely enough time to learn basic aerial maneuvers, much less the energy management tactics required to survive against F-4s flown by Americans with hundreds of hours of experience. The casualty rates reflected this training disparity as much as the equipment mismatch. A well-trained pilot in an inferior aircraft can sometimes overcome disadvantages through superior tactics and situational awareness. A poorly trained pilot in an inferior aircraft simply dies. The combination of inadequate training and obsolete equipment created a death spiral from which Japanese naval aviation never recovered. As experienced pilots died, the average skill level of surviving pilots declined. As skill levels declined, casualty rates increased. As casualty rates increased, training programs were shortened to produce replacement pilots faster, which reduced skill levels further, which increased casualty rates more. By the summer of 1945, Japanese fighter units were operationally ineffective, barely able to mount organized resistance against American air raids. The kamikaze campaigns represented the logical endpoint of this death spiral, converting the fighter force into guided missiles by removing the need for pilots to survive their missions. This appalling calculus, sacrificing pilots deliberately rather than losing them to American fighters, reflected the depth of Japanese desperation by war's end. The Corsairs that intercepted kamikaze attacks demonstrated their superiority in this role as well, using superior speed to intercept approaching Japanese aircraft and superior firepower to destroy them before they reached American ships. The kill ratio in these engagements sometimes exceeded 22-1, with Corsairs and Hellcats shredding kamikaze formations that lacked fighter escort. The captured Corsair at Kasimigara never participated in combat, never faced a zero in the turning battle that might have made for dramatic history. Its value was educational, not operational. It taught Japanese pilots and engineers exactly how far behind they had fallen, how completely American technology had surpassed their own. This lesson was unwelcome but necessary, stripping away illusions about the Zero's continuing relevance and forcing acknowledgement of reality. Genda would remember the test flights for the rest of his life, not as fond memories but as educational experiences that shaped his understanding of aviation and warfare. He learned that superior technology mattered more than pilot skill when the technology gap was large enough. He learned that industrial capacity was itself a weapon, perhaps the most important weapon in modern warfare. He learned that 417 miles per hour could be the difference between victory and defeat, between life and death, between an empire's survival and its destruction. These lessons informed his post-war service in building Japan's self-defense forces, as he emphasized training and equipment quality over numerical strength. Knowing from experience how much technological inferiority cost in combat, the Corsair itself, that particular aircraft with bureau number 57,251, burned in its revetment at Kasimigara in August 1945, destroyed to prevent its recapture. The ashes mixed with Japanese soil, a fitting if melancholic end for an aircraft that had taught such painful lessons. No memorial marks the spot. No plaque commemorates the test flights or the men who flew them. The aircraft simply disappeared into history, remembered now only in fragmentary records and aging memories. But the lessons remained, embedded in the post-war development of Japanese aviation and the broader understanding of industrial warfare. The 417 miles per hour that the Corsair achieved in level flight became a benchmark, a reminder of what American industry could produce and what Japan needed to overcome if it hoped to compete in the modern world. The captured Corsair was evidence of one war ending and another beginning. The transition from the illusions of 1942 when Japanese fighters dominated Pacific skies to the reality of 1945 when American superiority was absolute and unquestionable. The men who flew that captured fighter, who pushed the throttle forward and felt that massive engine respond, who watched the airspeed indicator climb to speeds no Japanese fighter could match, understood in the most immediate way what those numbers meant. They had flown both sides of the technological divide and knew which side they preferred to be on. The Corsair's 417 miles per hour was more than a specification. It was the sound of history turning, the measurement of empire's end, the quantification of a lesson learned too late to matter but remembered forever by those who were there to witness it. This untold chapter of aviation history reminds us that wars are won not just by courage and strategy, but by the industrial might that builds the tools of war. If this story captivated you, subscribe now for more deep dives into the human stories behind the machines that shaped the 20th century. History is written not just in grand strategies, but in the cockpits where men discovered exactly what 417 miles per hour meant for their survival and their nation's future. Thank you for listening.